Hello, everyone. Thanks for joining us today. We have a tech talk on three data structures in AI by Kaishar Mahmoodi. So, Kaishar, whenever you're ready, please take it away.
Hi, thank you, Lucas. Good afternoon, everybody. Thank you for attending my tech talk. Today, I would love to talk about tree data structures and their importance in AI. So I believe many of us here are fascinated by how AI can do such amazing things like holding conversations, solving problems, and predict and making decisions, right? So in our bootcamp, we haven't covered tree data structures formally yet, but this topic keeps popping up whenever I do some research about how machine AI learning works. So I wonder, so what is its importance in AI? So it turns out the tree data structures are like the hidden architecture behind AI's decision-making process. So we can imagine an AI that not only answers questions, but also anticipate needs and handles complex tasks. So at the core of these capabilities is the structure, tree data structure. So, but before we even talk about tree data structures, let's take a look at what is data structures in general. So, so tree data structure is a specific format for organizing, storing, and processing data within a computer system. So, as shown in the slide, the typical data structures that we have encountered, so arrays, linked lists, stacks, queue, tree, and graph. So I believe in the upcoming weeks, we will talk about them in detail in our cohort. So now let's take a look at the definition of a tree data structure. So tree data structures aren't just another tool in programming. They're a powerful way to represent hierarchical relationships and decisions. So think of a tree data structure as a family tree. So we can start with a single root node and that branches out into child nodes, which themselves can branch out in further nodes. We'll take a look at them for this example in this slides. So here, every circle is representing a node. So the topmost node is called the root, and every other node is descending from this root node. So a node can have a number of children in tree data structures. So for example, the root node P has two children, Q and R. They are connected with these lines. These lines are called edges. So every node has a key in them, which can hold any type of data. And so we have another concept called siblings, which is the nodes that share same parent is called siblings. And then in a tree, so they can have like subtrees, which is any nodes that can have their any node that has their own children can form a subtree. And then most importantly, the nodes without any children called leaf tree. And then leaf nodes. And then the height of the tree, there's a concept, the height of the tree. So we can count the height of the tree by counting the edges, starting the topmost root node till the lower leaf node. So for example, in this scenario, the height of the tree is 1, 2, 3, 4. Now, this is a simple explanation of tree data structures. Now let's take a look at different types of tree data structures that are used in AI. So we have decision trees, random forests, and search trees. They all have their own strength and they all have their own use cases in AI. Now let's take a look at decision tree. What is a decision tree? We can imagine an AI system in the banking industry deciding if a borrower is high risk or low risk by asking yes or no questions. So as shown in the graph, so so this AI will first ask, is the income is over $50,000? So if yes, it checks the credit history. A good credit leads to low risk, while bad or unknown credit results in moderate risk. So if the income is between $20,000 and $50,000, so good credit still means low risk, but bad or unknown credit leads to high risk. So if income is lower than $20,000, the person is immediately classified as high risk. So this decision-making process helps financial institutions quickly evaluate risk based on income and credit history. So just as decision trees classify data by breaking down their factors in a series of questions. Now let's take a look at random forest. So we can imagine a forest. So each tree in the forest represents a different decision tree. And instead of relying on just one tree, random forests use many. So each tree is trained on slightly different data, and they work together by voting on a final outcome. So the random forests are great because they reduce errors and produce uh, more accurate predictions. They're often used in areas like fraud detection, where having a diverse set of trees gives a more reliable result. So basically, you can imagine a random forest is the combination of many individual decision trees. Now let's take a look at what is a search tree. So AI often needs to explore different paths to reach an optimal decision, so especially in games and robotics. So this is where search tree comes into play. For example, in chess, AI uses a search tree to evaluate all possible moves. So each node represents a board state, and the branches represent the possible moves from that state. So the AI searches through the tree to find the move that gives it the best chance of winning. Now we have seen different types of tree data structures in AI. Now let's take a look at why we use tree data structures in AI. So we use tree data structures in AI because they're efficient in search and sorting data. So trees provide fast data retrieval with logarithmic time complexity through techniques like binary search and making them ideal for large data set. And they are really good at representing hierarchical relationships. So inherent parent-child relationship within a tree structure naturally models hierarchical data, like a company hierarchy or a file system and directory structures. So they're also dynamic structure. So trees can easily grow and shrink by adding or removing nodes. So adapting to changing data needs without major restructuring. So they're good at recursive algorithms. Many tree operations can be implemented using recursive algorithms, which are often intuitive and easier to understand, and their flexibility in operations. So depending on the tree type, operations like traversing, finding specific nodes, and updating data can be performed efficiently. So in AI, where decisions often involve multiple layers of dependencies and the potential outcomes, so trees can help us manage these complexities. Whether we need a model to classify data or navigate through a problem or make decisions under uncertainty, the tree structures provide a clear and effective way to model these situations. So to sum it up, tree data structures aren't just a tool, their blueprint for future of AI. So as AI continues to evolve and push boundaries, the tree structures will remain critical for solving problems efficiently. So from simple decision making to complex models, so trees provide the backbone for much of what AI can do today. So next time when you interact with an AI, remember that the tree structure is working behind the scene, making it all possible. They may seem simple, but their impact is profound, and they will continue to light the path forward as AI advances. Yeah, I would love to end my speech here today. If you would love to learn more about tree data structures, you can refer these materials here. So yeah, thank you. Any questions? Yeah,
Yeah, thank you, Kaishaer. Great tech talk.
thank you.
Um, Connecting these like two complex topics, right? And they're also like a practical application. So yeah, super
Yeah.
insightful. Um, yeah, who has questions for Kaishaer? Anyone? All right. I guess we have no questions. So yeah, thank you all for coming today.